Hello everyone. Welcome to this series of problem solving fundamentals. My name is Ashish and today we will be discussing about the most important topic, that is this time and space complexities. Now being that important, I have seen a lot of people struggle in this field and that's why I have thought to come up with this video. Now this is the part 1 of it and I'll be covering these 5 questions for you. What is time and space complexity? Why is this important? What is the max allowed limit? I mean in general when it comes to coding platforms and all, and how to know if your solution is the optimal solution or not, and towards the end, the pro tip, how it helps in your overall thought process. So stay tuned to this and let's get started. So what basically is space and time complexity? Well, that's a function describing the amount of time or space your algorithm takes for a given amount of input to that algorithm. So let's take an example. Say you have input, say n equals, let's say 20. Now, you have a program or algorithm which has like for loop and it runs from I equals 1 to 20. Now, and some operations. So that n equals 20 and you have a loop of 1 to 20. So it's simple. You have a time complexity of O of 20. Or let's say O of n in this case. If n becomes 100, so this 20 is 20 nanoseconds. Now it will take 100 nanoseconds, O of n. Similarly, if n becomes 10 to the power, let's say 8, it takes 1 second. And how did I find this? I'll explain you. So that's what basically a time complexity is. Now let's take the second question and see why it is so important. So it is important in terms of, say, industry perspective. We want our customers or our clients to have a flawless response. Imagine you are searching something on the Google and it takes 5 minutes to give the response. Now that's not a pretty good customer experience, and that's why we focus more on these optimizations. Now from the interview point of view, it is important in terms of, say, interviewer asks you a question and you directly don't give an optimized solution, rather you gave a brute force approach, then you give another optimized solution, maybe another one, you gave like first approach, you gave a second approach, you gave third approach. So you give multiple approaches and multiple solutions to the interviewer. Now out of those you have to pick one best solution, and you can do that only if you know which has the most efficient time and space complexities. Now let's take an example. So, given an example of an array, let's say an array is sorted, and I'll take here, say, it is 3, 5, 9 and 12. So, given this array and given an k equals, say 9 plus 3 is 12. Now we have to find two elements here whose sum equals k. Now in this case 3 and 9 are the two elements. So the given array is sorted. So let's say forget about any optimized solution and think of a naive approach, that is the brute force approach, and you take one element, that is 3, search for everything in the array and you found another element, and you go to the second element. Let's say the given k in this case is 5 plus 2 is 17. Now you started with 3, you don't find anything. You started with 5 and you search for this and you found that 12. So at the worst case, what you will do is you will have a complexity of n square, right? Because there are two loops. Now second approach, let's say you are taking a binary search approach. You come up to an element and you do a binary search. Now for each element, and binary search takes log n time, so it's n log n and log n. Log n is the binary search, and for each element you have to jump. Now let's think of some other approach. You start with a 2-pointer here and here, and then you move towards the middle to find a better solution. Let's say in this case it is 12 plus 3 is 15, so it is like smaller than k, so you move one step ahead and you found it. So that will take n time, O of n time, right? So only if you know all these time and space complexities and all these things are one space, right? So constant space, that is. So only if you know all these things, you'll be able to pick up the best solution. And that's what makes it important in terms of interview. Now let's think about what is the maximum allowed time and space complexities and how would you know that your solution is optimal solution or not. Now let's take an example. Given n equals 100, right? And your time complexity came out to be O of n cube. Now O of n cube maybe sounds not an optimal solution, but probably this is. Let's say O of n cube becomes 10 to the power 6 in this case, right? So 10 to the power 6 is equals 10 to the power minus 3 seconds, or it can be 1 millisecond, right? And let's say n given for me is, let's say, 10 to the power, let's say, 18, okay? And in this case, even O of n solution is not an optimal solution because that will take 10 to the power 9 seconds. How did I do that? I'll explain you. So, knowing this time complexities and the maximum allowed complexities will help you determine if your solution is optimal enough or not. And what is the maximum allowed capacity? Let me come to that. So when you come to a situation like giving a problem solving interview or doing some coding interviews, coding practices on coding platforms like HackerRank, LeetCode or CodeChefs, etc., we can generally assume that these systems have a processor of 1 gigahertz. Now there is no hard and fast rule that it is 1 gigahertz, but in general it is safe to assume that. Now, a system performance depends on a lot of factors like the processor, the RAM, the architecture, like the 64-bit or 32-bit, and all of these things. So taking one general example, so we can say like 1 gigahertz processor is something which is given to us, and that becomes like 10 to the power 9 clock cycles per second. Now again, in general, one CPU we can think of executes one, or the one clock cycle is in general one instruction we can think of instruction. So 10 to the power 9 clock cycle becomes 10 to the power 9 instructions per second. Now what basically is the instruction? A plus B instruction. If condition something is an instruction. With a lot of instructions in a loop, there can be a lot of cases. Now, so at any case, our algorithm should not exceed this 10 to the power 9. Otherwise, it will take more than 1 second. And that is not allowed for us. Okay? Now, 10 to the power 9 instructions, but your algorithm can have a loop of say 1 to 10 to the power 9. And that can have like multiple instructions. That will eventually exceed the 10 to the power 9. So in that case, to have a margin of safety, you can say, and we can give an estimation like n should be less than equal to 10 to the power 8. Okay. But these are like minimal time consuming, so we can just give some margin to that. So our max allowed capacity becomes 10 to the power 8. So for time complexity. Similarly for space complexity, I will explain you, but just to write it, it should be within 10 to the power 6 to 10 to the power 7. And how is it? I will explain you in some other videos when I start with space complexity. Let's take some examples and try to figure out like how this all fits into. Let's say we are given an example of n equals 10 to the power 6. Okay, and we have time complexity of big O notation. Let's say it is let's say this big O, which is n cube. Okay, so n cube becomes 10 to the power 18, right? So 10 to the power 18 iterations or the instructions can become for a 2 time consuming. It will be like 10 to the power 9 into 10 to the power 9, and this takes 1 second, so that will becomes 10 to the power 9 seconds. Now divided by 60 to convert into minutes, then to hours, then to days, and then to years. And if you do the math, you will figure out it is 31.7 years. Now you have a solution which takes 31.7 years. Now that's not a pretty good solution. Now let's take another example of n square, which becomes 10 to the power 12, and that is again more than 10 to the power 9. Again, it's not sorry, 10 to the power 8, not again very acceptable. Let's take log of n solution, and these are okay, log of n. So log of 10 to the power 6 is 20. Yeah, so that takes 20 nanoseconds, and that's good. Now imagine 2 to the power n solution in this case, and let's say n equals, and so this is how you can see, like, given an input, how these complexities vary and how much time is going to take. And we have a max allowed of 10 to the power 8 in terms of time complexity, and that will take a max of 1 second, and this is something to keep in mind. Now let's say n given is equals 30. So in this case 2 to the power 30 it becomes, and you do the math and see if that is passing or not. Then do 2 to the power 60 given n equals 60, and see how much that is coming up to, and see if that is going to pass or not. So thing which I'm trying to explain here is, when you are interviewing at some place and you have multiple solutions in your hand and you are calculating the time and space complexities, you can safely keep this in mind and figure out the things, if those are optimal or not. So now to the last question and the pro tip. So when you're given a problem in an interview, or you're solving any question on any of the coding platforms and you came across these constants, let's say the given constraint is, let's say n equals 10 to the power we can say 10 to the power 6. Now seeing at this constraint, you can say now the n should be less than equals, let's say 1 to 10 to the power 6. Now looking at this constraint, you can think of let's say you have a solution, or a brute force solution, which takes O of n square time. Okay, you're not writing any question, any solution here, but you're just thinking about it, and that will be like 10 to the power 12, and which is greater than 10 to the power 8. So if this is the case, you know that the n square solution doesn't work out. Let's take one step ahead and think of if n log n really works or not. So this becomes 10 to the power 6 into log of 10 to the power 6 becomes 20. So that will take like 20, yeah, this is the total seconds it is going to take, and yeah, so 10 to the power minus 3, not the seconds, into 20. Okay, so that will take 20 milliseconds, and this solution is going to pass. So what you can observe from here is, if n log n solution is working out for you, that means what you can think of, what all things can lead me to an n log n solution. Maybe sorting, because fastest sort can take n log n time, merge sort or quick sort, like that. So in this way it helps you determine before even thinking about any logic, that what all approaches can be taken, that might be taken. I'm not saying that this is the whole approach you are going to take, but that's what you can have in your mind. Let's take another example and everything will be clear from that. The first example which I have explained, let's say there is an array of 3, 9, 2, 6, and you have to find, and a given k is of say 15. So you have to find two integers in this array whose sum is 15. In this case it is 9 and 6. Now given this array, if you take one, and the total value of total length of the array can be say 10 to the power 6 again, the max allowed should be less than 10 to the power 6. Now if you take a n square solution, take one element and search for the rest, take another element and search for the rest. So in this case again it is n square, and it will be taking like this much time complexity. Now so n square solution which you have a brute force solution doesn't work out. Now let's think of if n log n works out. Yes, that takes 20 milliseconds, so that is going to work out. So let's sort this thing, and it becomes 2, 3, 6 and 9, and then we can see sorting takes n log n time, plus again we have to search, so again n log n, which becomes a big O of n log n time. So that solution is going to work out. So looking at the time constraint, we can see if your solution is working out or not. And that's how you can think of in your back of your head, like before even going towards any algorithm, like if that approach is optimal or not. So yeah, so I think that helped to clear the fundamental. I'll be explaining in a couple of more parts how to derive for the time complexities and space complexities and stuff like that. Do subscribe to my channel and see you until next time.